Swayam Prabha. Digital India. Educated India.
Hello everyone, our today's topic is yarn linear density. So we have earlier discussed the fiber fineness or fiber linear density. Similarly, yarn linear density we measure as a representation of fineness. So fine, again, the textile material like yarns are not uniform in diameter due to the application of twist. So we express the yarn fineness in terms of linear density. So here we will discuss different analytical approaches, how to calculate the yarn linear density and their interpretation. Now if we see the system of measuring the fineness of yarn, it is basically in terms of linear density. That means owing a known length of yarn and this quantity is known as linear density. And we can measure it with a high accuracy if we take sufficient length, so that the error is reduced. So we express the yarn linear density in the two systems. One is the direct system, another is the indirect system. So direct system, where we measure the length of the yarn and then take the mass, right, and we express the mass per unit length, that is W by L. And the indirect system is just reversed. Okay, so for a certain mass we measure the length. Okay, so length per unit mass. So as it is called direct system, this system is easy to understand. So we take the unit length and then take the mass. So mass per length, if the mass is more high, that means the yarn will be coarser. So for a certain length, this is certain length of yarn. So for constant length, we take the one is coarser yarn, another is finer yarn. So yarn A is thicker, yarn B is thinner. So if we take the direct system of measurement, the yarn A will have for unit length of L So this will, yarn A will have weight WA, yarn 2 will have weight WB, WA is more than WB, so the linear density will be higher. But in indirect system, it will be just reversed. So first let us discuss the direct system. The linear density is defined, as I have mentioned, measuring the mass per unit length of a yarn. So it's a fixed length system. So here the length is fixed. It's called fixed length system. So we have the unit length, a fixed length, and then we take the mass. So lower the number, lower the mass value, finer the yarn in terms of count. Although we frequently use this as count, but I have kept this term count here in case of direct system deliberately because this is wrong. We should not use the term count because here we are not counting anything. So here we can call it as yarn number. So lower the value of mass. So that is mass number. Finer will be the yarn. So there are different systems available. We can express the yarn linear density in direct system by different expressions. Very commonly used expression is TEX, where mass of yarn in grams per 1000 meter. For 1000 meter, what is the mass? This TEX is normally used for yarn or sliver or roving. Another term which is for finer material, which is 9 times finer, the denier is defined as grams per 9000 meter, which we have already discussed in case of fiber. For fiber we have discussed, we use the term denier. Another term which is used, this is again mainly for fiber, is a decitex, that is 1/10 of the mass. That is, here length unit is 10,000 meter. So mass per gram, mass is in gram per 10,000 meter, 10 kilometer yarn. So you take 10 kilometer yarn and then take the mass, whatever the mass is coming in gram, that will be considered as decitex of the. Now let us see the general relationship for direct system. This is N is the linear density in a particular system. So in the yarn number, again yarn number we can say L is the length of the sample, actual sample what we are using. M is the mass of sample at its official regain in the unit of the system. That means if the mass is say 5 gram, so here the unit was gram by definition. For text, the mass unit was gram and length was 1000 meter. Length was 1000 meter. So L, the unit length of the system. That means L is here 1000 meter. Now let us see one example for the direct system. That is direct system, we can call it as linear density, or indirect system normally we call it as the count system. That I will discuss. If the mass of 560 yarn is 25 gram, the linear density will be in text will be, so definition of English count, as although we have not discussed here, that this I will come later. Okay, this part I will come later after discussing the indirect count. First let us discuss the indirect system. This indirect system is basically traditional method of yarn linear density. It's a traditional method, still we are using in the industry. And as it is traditional, it has got certain history. I will discuss little bit of the history of generation of indirect method of measuring yarn linear density. So this is based upon length per unit mass of the yarn. Okay, we need to have certain mass, and then we calculate the what is the length of the yarn used. So it's a called fixed mass system. Indirect is fixed mass system, direct is fixed length system. So here in direct system, higher the number, coarser was the yarn. But in indirect system, higher number means finer is the yarn. So the main systems for indirect system are cotton count, which is very commonly used. It's a number of hanks of 840 yards length in 1 pound. So that's why in here we can use the term count, because we are measuring the number of hands. Now the story behind this is that when the workers, those who are winding the yarn, the wage was actually based on the number of bundle they produce. Bundle of 1 pound. 1 pound bundle. So you have to produce 1 pound bundle, then you will get certain wage. Okay. Now, one worker, he is actually making hanks, winding hanks. So hank means 840 yards of yarn. So 1 li, he is making li with the hank winding machine. 1 li contains 120 yards. 120 yards means the circumference of this wrap reel is 1.5 yard and it has got 80 wraps, so 120 yards. And such 7 leaves he is winding at a time and making one bunch, and this bunch is called hank. 7 multiplied by 120, so 840 yards he is making bunch. And there is a weighing balance. This is the weighing balance, and this hank he is putting on it, on the weighing balance. So number of hanks he is producing, so he is putting 1 by 1. So after say 20 such hank, when he is winding, this is becoming 1 pound. This has become 1 pound. So 20 is the count. He is counting the number. How many hanks are placed on this to make it a bundle of 1 pound. So then he is making a bundle, and this is a bundle, and in this bundle he is putting a number 20. Similarly, another worker, he is also doing same thing, and in his case, in the bundle, when he puts 30 such hanks, then it becomes 1 pound. after putting 30, that means he is counting the 30 hangs, 1, 2, 3, 4, like this, 30 hangs. Then it has become, both of them are producing 1 pound. But the second person who has actually put higher effort, more effort than first one worker, and he has produced 1 pound. So both of them produced 1 pound each, but here he is counting the number of hangs and he has put 30. So in both the cases, so they have produced 1 pound. What does it mean? The first person, whatever yarn he has wound, the yarn was thicker one, coarser one, because 20 such hang weighs 1 pound. Here for the second person it required 30 such hangs to make it 1 pound. So the 30, the count is the finer one. So if we try to, both of them are, suppose they have produced 1 pound each, but the wage should be given, more wage should be given to the person two, second one, because he has produced the number of hands, more number of hands. So 30, his effort required was 30. So as this is, the weighing is based on the number of hangs, that is, he is just counting the hangs, number of hangs. So that's why this is called count. And this system was, the 840 yards was actually used in case of cotton yarn. And it was used in UK, England. So that's why this is called cotton count or English count. E stands for English count. So here, the lower the value, coarser is the yarn. Just opposite to that of direct system. Similarly, for worsted yarn, the similar story was there for worsted yarn, but one thing is different here. In cotton system it was 840 yard, but in woolen system, worsted system, it is 560 yard. The reason being, wool yarn is little bit bulky in nature. If we try to make the 840 yards of hang, then it will become very, very bulky. So that's why the hang size here is reduced for 1 pound of a package. This is mainly due to the bulkiness of worsted yarn. Metric count. This is metric count is another system of indirect numbering. Here number of kilometer per kilogram. So if we take 1 kilogram yarn and if we measure if there is a 20 kilometer yarn, so the metric count Nm will be 20. So here the relationship again, N is the count in indirect system, A length of the sample, M unit mass of the system, and M is the mass of the sample at the offshell of the in the unit of the system, and L is the unit length of the system. Like in cotton count system, it will be 840 yards. Now try to see this numerically. .560 yard of yarn weighs 25 gram. The linear density in text. So cotton count, length in yard, mass in pound by 840. And length in yard and mass in gram. Here directly this factor 0.54 we get when we use the cotton system. Now let us see how is it coming. 1 pound equal to 453.6 gram. Okay, 453.6 gram. Now if we convert this length mass in pound, that means here in gram will be 4 gram by 453.6 mass in gram. So it will be 453.6 by 840 mass in gram by length in, sorry, just 453 length in yard, length in yard and mass in gram. So 453.6 divided by 840, it comes out to 0.5. So directly from here we can use this formula directly. So this will equal to, so 0.54 into length in yard by mass in gram. So 0.54 length in yard is given 560 and mass in gram. So it will become 12.09 in. and the relationship between text and English count, that we can, from the definition, we can get this relationship in E multiplied by NT. So English count multiplied by text count is 590.5. This conversion one can get from the basic definition and only simply unit conversion. This is the conversion factor. So if we know the English count, then we can calculate the text value. So text is 590.5 divided by 12.09. It will be 48.84 text. Another numerical, the length of 4.4 kg of 25 text yarn. So length we need in kilometer. So here, from the earlier relationship, this is 1000 meter from the definition of text, gram by text, mass in gram. So 4 kg, 4.4 kg, 4400 gram. So from there we can calculate the length in kilometer. Okay, this is in meter, and from there we can calculate directly length is kilometer. These are the very simple numerical. So another numerical similar type, where you can see text is mass in gram, length in meter, and length unit. So mass in gram 5 kg, so 5000 gram, 1000 is the length unit, and length in meter of the yarn. So text was given 60. So length in meter will be 83333. Okay. And in kilometer, 83.33 kilometer. So these are straightforward calculation. Another numerical, so mass of 640 yard yarn. So we have got 640 yard yarn, and we weight is 40 gram. What is the linear density in text? So what we know the relationship between the English count. So any equal to 0.54, as we have discussed, length in yards by mass in gram. So 0.54 yard is given 640 divided by 40. 8.64 is the, so you can see 8.64. So as we have English count, so we can get the text value. Here text was asked, so text is 590.5 divided by English count. So we will get the value, sorry, any is 8.64, so it is 68.34 texts. We have discussed. Now if we see the, we have seen that different types of counts are used both in direct system and indirect system. So there is a chart available for ready references. Here the text, decitext, denier, metric count, English count, they are given, and from this chart you can see the metric count from text value. We want, if we want to convert to say metric count, so 10 texts, if the text value is 10, so metric value will be, and English count will be 590.5 divided by 10, it will be 59.05 English count. So from this chart directly we can convert. All this conversion factor is derived from the, these are derived from the basic definition of the particular unit. So if we see here, this is conversion from direct to indirect system, and here conversion is from direct to direct system also, and here indirect to direct system also. Now let us continue. The length of 45.5 NE cotton yarn on a 1.5 kg cone. So mass is given and English count is given. So from English count, we should convert it to text count. So text and English count relationship we know, which is 590.5. So text is 590.5 divided by cotton count or English count. So the text becomes 12.94 text. Now 12.94 text yarn, its mass is 1.5 kg, so that we can convert it to length of this. So 12.97 text means if we take 1 kg, 1000 meter of yarn, it will weigh 12.97 gram. So 12.97 gram weighs 1.5, sorry, weighs 1000 kg, 1000 meter, 12.97 gram, weighs one length 1000 meter. We want length in kilometer, so it is going, that means 1 kilometer, 1 gram will weigh 1 by 12.9 kilometer, and 1 gram, that means 1.5 kg means 1500 gram, 1500 by 12.9 kilometer. So 1500 by 12.9, 100.6, this much kilometer. So in this way we can calculate 115 point, this is in meter, and kilometer will be 115.65. So knowing the length of the yarn is very important. We can calculate the mass of a cone. Mass of a cone is, we can calculate directly by measuring the weight, weighing balance, but the length is extremely important for manufacture, actually using the yarn in during knitting, weaving or warping, sizing. So we need to know the how much length of yarn is present. So for that, actual yarn count or linear density is important. Again, let us see length, again in kilometer, of 3 kg of 30 nm worsted yarn. So we must know the definition of metric count, and from the definition of metric count and the definition of text count, text system, so the relationship, as we have seen, it's 1000 by nm, so 1000 by 30, so it will be 33.33 tests, and from there we can calculate the length of the yarn in meter, 1000 mass in gram by text, so 3 kg, 3000 gram text, and this 1000, so it will become 90 kilometer. So this is meter, if we divide it by 1000, so it will be 90 kilometers. Now let us try to see which yarn is the finest, the linear density of which yarn is the finest. So we can express the yarn, we can get the yarn in different systems, and we must know which one will be finer. If we have to select the yarn, finest yarn among 60 nm, this is yarn 1, yarn 2 is 20 ne, yarn 3 is 15 ticks and yarn 4 is 170 denier. Now let us try to see which one is finer. As we have discussed, in indirect system, the finer the yarn, higher will be the number, and in direct system, finer the yarn, lower will be the number. That means the higher value of, say, text means coarser yarn. Basic idea of this type of problem is that to know, to select the finer one, and the approach we should use to convert into a single count from all different count system, different units. We have to convert it to a single unit, any one of these. So let us do it in text system. Convert it. The text is very widely used internationally. So text system is acceptable everywhere in the world. Even English count, any, is not acceptable everywhere. Although for cotton count, we use very frequently English system. So 60 NE NM, let us convert it to text. So it is becoming 16.66 text. 20 NE, 20 NE means 29.53 text, and 15 text is already in the text value, and 170 denier, denier and text conversion is 9, factor 9. So 170 by 9, so 18.88 text. Now higher the text value, so coarser will be the yarn. So as 15 text is the lowest, so this yarn will be the finest yarn, and the coarsest yarn will be 20 NE yarn. So 15 text is the finest yarn. You can see the a twistless polyester yarn has 100 filaments, each of 4 denier. So 100 filaments are there and 4 denier. So 4 denier. So total denier of yarn will be 100 multiplied by 4. So 400 denier, and from 400 denier we want to convert it to metric count system. So text, first let us convert it to text. So it will become 44.44, and then metric count system, 1000 by text, so it is 22.5. So we can convert based on our data available. We can get the linear density in different system. Now this is one interesting numerical. If the numerical value of yarn linear density is expressed in text and in metric system is the same. So numerical value in text and metric system is same value. So what will be this value? So we know N E English count multiplied by NT 590.5. So any value is equal to NT English that. So we can just replace any with NT. NT multiplied by NT equal to 590.5. So NT will be under root 590.5. It will be 24.3. This 24.3 is the value where NT and NE coincide, numerical value. Suppose this is the mean line, one line, imaginary line of finer yarn of say English count, NE is NT. So if the yarn is very fine, the value will be high, and in text the value will be low. Now if we it's very fine, same yarn very fine. Now little bit coarser, and the same yarn little bit coarser, now other yarn coarser, this is becoming the text has coarser, so text has increased. NE has decreased. Further coarser, NE has decreased, text is increasing. In this way, if we keep on doing, there will be one point where the values are exactly same, and that value is 24.3. So you can see here now. This is for NE and NT, English and text. Now if we try to do for text and metric count, so text and metric count, the relationship is that NT NM 1000. Here it was 590.5, it was 1000. With the same concept, if we replace NM by NT, so NT square equal to 1000, so NT will be under root 1000, it will become 31.62. So we can do for other count systems also. Now let us try to do another numerical. If the numerical value of yarn linear density expressed in denier and the metric system is same, what will be the first? What will be the value in worsted system in W? Now first try to see the relationship between ND by NM, denier and metric system. Denier and metric system. So metric count equal to 9000 by denier. So Nm, Nd. So Nd and Nm are same. So we can consider Nm square will be 9000. So Nm value will be under root 9000. So the value comes 98.866. So 94.868 denier. Now from this denier or 94.868 metric count. From this we can convert it to Oersted count. So denier is known. So from their English count we can calculate. The relationship is 5314.5 by denier. So English count is 556.02 and Oersted count and English count relationship is factor is 1.5. If we multiply by 1.5, it will become 84.03 Oersted count. So we can convert from one system to another system, and here that means 94.868 is the value where denier numerical value and metric numerical value they coincide. So this we have already discussed. Numerical values of yarn linear density expressed into text and English system, it is same, then value will be under root 590.5, that is 24.3. This we have already discussed.